Hi there. It's nice to have you back drifting in with us tonight. Tonight, we're not staying in the present. We're stepping back, far back into March of 2024. A world where the phrase, "Wait, did you see the size of that asteroid?" was trending on a little bluebird website that had just changed its name again. It began, as all great changes do, not with a bang, but with a barely perceptible stillness, a quiet subtraction from the perfect, humming balance of the night sky. Imagine the darkness, not as an absence of light, but as a vast, ancient sea, and every star a distant, diamond-sharp buoy. For 1,000 millennia, the navigators of the universe have counted on the rhythms of this ocean. But what if one of those buoys, a temporary speck of cosmic dust, didn't just pass through, but rather slowed and then stopped in the middle of our navigational chart? This wasn't an asteroid. It wasn't a comet, at least not one that followed the predictable, looping poetry of Kepler's laws, those perfect, elliptical whispers of celestial mechanics that govern the motions of everything from the smallest mote of space gravel to the gas giants. No, this was 3I Atlas. The official report from the astronomers, dutifully filed on the 29th of October, 2025, was dry, stating a hyperbolic orbit with an eccentricity value of 1.00003, a number that sounded reassuringly close to a comet on a one-way trip. A simple slingshot. But what the news didn't convey, tucked away in the footnotes only the most persistent stargazers found, was the sheer geological improbability of that perfect, vanishingly subtle excess of speed. It was traveling too fast to have been born here, but then its trajectory began to betray a strange, almost hesitant quality. It was a contradiction wrapped in a light curve, a deep space rogue that, against all the odds, seemed to be gently applying the brakes. The air feels sharp and dry tonight, doesn't it? As you settle down, imagine standing on a ridge, overlooking the sleeping Earth, looking up at that vast, silent archive of time. We've always told ourselves that visitors from beyond our solar family are bound by the simple, beautiful physics of gravity, merely a gravitational footnote in our history. But what if this one wasn't supposed to happen that way? What ancient, silent echo does this object hold? For centuries, our ancestors looked to the heavens and saw gods and monsters, not just physics equations, the wandering star, the celestial messenger, the thing that came and did not go back. What if 3I Atlas is that ancient tale, rewritten in the cold, clear language of astrophysics? Settle in and let your curiosity be a quiet anchor. We're going on a journey through the implications of a celestial object that is, for all intents and purposes, acting impossibly still. Leave a comment telling me what time it is and where you are listening from, and let's begin to unspool the thread of this quiet, cosmic mystery. The silence that accompanied the initial observations of 3I Atlas was not the silence of an empty void, but the pregnant quietude before a fundamental axiom is gently, almost apologetically, challenged. You and I, we are accustomed to the celestial dance, a grand, complex ballet, where every participant moves with a deterministic precision that has allowed human minds to predict solar eclipses and planetary alignments millennia in advance. This entire cosmic theatre is ruled by Newton's universal law of gravitation, a beautiful framework that explains the elegant, looping paths of comets, those icy, dusty messengers from the far, cold frontier of our own solar system. They spend countless tens of thousands of years in the vast, spherical shell we call the Oort cloud, a whispering gallery of frozen remnants that might stretch out to 50,000 astronomical units or more, a distance so immense that the light of the sun, that generous, life-giving light, is but a pale, distant star from that lonely region. Our initial understanding of 3I Atlas, based on the preliminary data from the Panoramic Survey Telescope and Rapid Response System, or PANSTARRS, a mouthful that is often abbreviated simply as ATLAS, was that it was an interstellar interloper, an object born around a different star and jettisoned by some powerful gravitational scattering event. And the mathematics, at first, seemed to support this narrative perfectly. The concept of a hyperbolic trajectory is easy enough to grasp, though its implications are profound. Imagine tossing a stone upward. It goes up, it momentarily pauses, and it falls back down, describing a parabola, a closed curve. This is the bound orbit of our comets and asteroids, forever tethered to the Sunday. But imagine throwing that stone with such incredible, impossible velocity that it overcomes Earth's gravity and continues to move away forever, describing an open curve, a hyperbola. This is the escape trajectory, the path of a truly unbound object. When 3I Atlas first swam into the view of our terrestrial telescopes, its trajectory possessed just that escape velocity, traveling at a slight, almost imperceptible excess speed that marked it as a visitor, a galactic tourist passing through. This excess speed, often referred to as a velocity at infinity, was calculated to be just a few kilometers per second, say 4 or 5 kilometers per second, above the threshold needed to leave the sun's gravitational embrace. It was an intergalactic goodbye kiss. But then, as the orbital parameters were refined over subsequent weeks and months, a subtle, strange pattern began to emerge, a whisper of a gravitational ghost that simply shouldn't have been there. The first anomaly, which we'll call the velocity stutter, was the most difficult to process. The calculation, based on its distant position, suggested that it should have been accelerating smoothly as it fell toward the sun, like any object succumbing to a gravitational pull. Instead, the astronomers noticed a very slight but persistent deceleration, not enough to capture it, but enough to muddy the otherwise crystalline waters of its expected motion. This change was minuscule, on the order of mere millimeters per second squared, a change so small you'd be laughed out of a typical physics lab for even attempting to measure it in an earthbound experiment. The simplest, and therefore the scientifically preferred, explanation for this non-gravitational acceleration is the outgassing of volatile materials, a jet effect, essentially a tiny rocket engine powered by the sublimation of ice from the comet's surface as it warms near the Sunday. This is perfectly normal for comets, the very mechanism that creates their beautiful tails. However, 3I Atlas was still too far out, beyond the orbit of Jupiter, where the sun's warmth is too diffuse to trigger the kind of powerful outgassing that would account for the observed braking effect. The sun's heat, at that distance, is just 1/25th of what we feel here on Earth. A very, very faint warmth, a mere suggestion of heat. The second anomaly, the rotational quiet, compounded the mystery. If the deceleration was indeed caused by jets, those jets should be distributed somewhat randomly across the cometary nucleus, causing a noticeable, even if slight, wobble or change in the object's rotational period. But the photometric data, the measurement of its brightness over time, showed an object that was remarkably stable. Its rotation period, estimated to be around 7.7 hours, was steady, a slow, gentle turn in the cosmic dark. No violent spinning, no unpredictable tumbling. If a tiny rocket engine was subtly pushing it backward, it was an incredibly symmetrical, impossibly balanced set of thrusters, firing with a perfect, coordinated elegance that simply is not seen in the chaotic, geological processes of a comet's death throes. It was almost as if the braking force was being applied from within, by a deliberate mechanism, or by an unknown physical process that defies our current understanding of icy body dynamics. And finally, the third anomaly, the color shift, made everything feel deeply, historically strange. Most comets, being covered in ancient, irradiated material, are dark, a sooty, deep, almost velvet black, reflecting only a tiny fraction of the sunlight that falls upon them, often possessing a reddish or brownish hue due to the presence of complex organic molecules known as tholins. But as 3I Atlas grew brighter, approaching its closest point to the sun, its color began to subtly, but definitively, shift toward a pale, almost bluish gray. This color is typical of fresh, pristine water ice, or very pure, unprocessed silicate dust, the kind of material that should have been long ago cooked off by the sheer radiation exposure of traveling across interstellar space for millions of years. It was almost as if its surface had been recently, and gently, stripped away, revealing an unblemished, newborn core. Imagine holding a handful of sand that has been sitting on a desert floor for 1,000,000 years. It is rough, dark, and wind-scoured. Now imagine finding a single, smooth, pale pebble buried underneath, one that has never seen the light of day. That pebble is the color shift of 3I Atlas. It was traveling too fast to be from here, but it was physically too pristine to have been traveling for that long. It was the subtle paradox that suggested a history far more complex than a simple flyby. As the great German mathematician and philosopher Gottfried Wilhelm Leibniz once put it, nature never makes leaps. But 3I Atlas seemed to be quietly challenging that assertion, taking a graceful, almost silent, jump in the cosmic narrative. We were faced with an interstellar object that was slowing down, not wobbling, and shining a newborn light. And this simple collection of odd data points begins to whisper about the possibility of something mythic, something archetypal, something that the ancients might have called the wanderer's return, the one who leaves the village only to turn back at the last moment, drawn by a mysterious, unseen cord. To understand the gravity, both literal and metaphorical, of this subtle tug, we must now delve into the very dust and ice that formed it, and ask if any object, regardless of its origin, is ever truly unbound. The physics of interstellar travel, as we shall see in the next segment, is far more subtle and far more unforgiving than a simple push into the dark. Let's take a cosmic zoom out, leaving the cozy, familiar confines of our own solar neighborhood, and enter the vast, truly empty, cathedral-like space between the stars. The interstellar medium, or ISM, is not a perfect vacuum, but a sparse, incredibly thin soup of hydrogen and helium atoms, dust grains, and cosmic rays. If you could hold a cubic centimeter of that space, you would find only a handful of atoms, compared to the 27 million atoms that reside in the same volume of air you are breathing right now. It is a space so vast that it truly defies our terrestrial intuition, a realm where light, the fastest thing in the universe, stretches its speed limit to the ultimate extreme, taking tens of thousands of years to cross the great galactic divide. This is the great ocean that 3I Atlas sailed across, and this journey, as we will explore, is far from a serene, undisturbed passage. It is, in fact, an incredible gauntlet that must have shaped the object in ways that now seem to contradict its pristine appearance. Imagine the nucleus of 3I Atlas, a cold, irregularly shaped collection of frozen gases, silicates, and dust, perhaps a few hundred meters across. It is traveling at a blistering pace relative to the ISM, perhaps 40,000 miles per hour or 64,000 kilometers per hour for millions of years. In the realm of orbital mechanics, this is a respectable, but not impossible, speed. Over this unimaginable stretch of time, it would have been constantly bombarded by cosmic rays, those high-energy particles flung across the galaxy by supernovae and other cataclysmic events. This constant, high-energy exposure is a process called space weathering, and it's a geological force far more potent than the gentle winds and rains of Earth. The cosmic rays impact the frozen surface, breaking the chemical bonds of the ice and dust, forming a dark, reddish-brown, tar-like crust. This crust, composed of those aforementioned organic molecules known as tholins, acts as a protective shield, darkening the object and sealing away the pristine ice beneath. The color shift that 3I Atlas exhibited, that transition to a pale, bluish-gray as it neared the sun, suggests that this million-year-old crust was somehow, and quite recently, removed. The simple explanation for this kind of event would be a catastrophic tidal disruption or a violent outgassing event, perhaps a close encounter with a star or a giant molecular cloud in its distant past, an encounter that blasted the surface clear. But if such a violent event had occurred, it would have surely destabilized its rotation, leading to the chaotic tumbling that the photometric data failed to show. It would have also likely cracked the object completely, leaving behind a rubble pile, not the seemingly stable, non-wobbling nucleus that 3I Atlas presented. The planetary science community, including leading researchers at the European Space Agency, or ESA, were quietly wrestling with this impossible combination. An ancient traveler with a newborn face. This brings us to a historical humorist's point about cosmic anonymity. For most of human history, objects like 3I Atlas simply did not exist in our conscious catalogue. We didn't have the survey telescopes, nor the computational power, to track them. Before the year 2017, the year of Oumuamua's discovery, the first confirmed interstellar visitor, we simply assumed they were out there, like mythical sea monsters that we just hadn't seen yet. Our solar system was, in our minds, a closed-off, self-contained system, and the Oort cloud was its outermost wall. We imagined the vast distances as an effective quarantine. Now, with the discoveries of both Oumuamua and 3I Atlas, we realize our solar system is not a walled garden, but a busy, galactic highway rest stop. We are now tasked with retroactively making sense of a history of passage we didn't even know was occurring. The planet doesn't keep a diary, and it certainly doesn't issue visitor passes. And yet, this simple passage through the ISM, the interstellar roadside, leaves telltale chemical and rotational markers on every traveler. The contradiction of 3I Atlas lies in the clean sheet of its identity. It is as if a lone adventurer arrived at a distant port after a 1,000-year sea journey, but their clothes were unrumpled, their skin unweathered, and their vessel unscarred. The sheer, relentless force of space weathering should have rendered it a dark, inert, highly processed object, reflecting very little light. Instead, the pale blue signature suggested that we were seeing not the ancient traveler, but something that had recently been refreshed, renewed, or perhaps even engineered. This naturally brings up the question of non-gravitational forces. If outgassing is too weak, too asymmetric, and too far away to explain the deceleration, what else could be subtly applying the brakes? Could it be the gentle, persistent drag of the hydrogen and helium atoms in the ISM? Calculations by astrophysicists at institutions like Harvard University's Galileo project have shown that this drag is utterly negligible, insufficient to account for the observed deceleration by many orders of magnitude. For an object the size of 3I Atlas, moving through the thin ISM, the drag is less effective than a fly trying to stop a freight train. The mythic echo here is the ancient Greek concept of kleos, or glory, often associated with a homecoming that is simultaneously strange and familiar. The Odyssey is, at its heart, the story of a traveler so changed by his journey that his own home barely recognizes him. 3I Atlas is a cosmic Odysseus, arriving home with an unrecognizable face, and yet its trajectory is whispering a subtle deceleration that suggests a reluctance to leave. It is the slowing down that makes it feel less like a passive piece of rock and more like an intentional visitor, or perhaps an object in a controlled, non-natural state. As you listen to the rhythmic cadence of the narration, let your mind drift to the idea of this tiny world, traversing the dark for millions of years, enduring the silent, grinding forces of cosmic radiation. And then, at the last moment, slowing down, we must now turn our attention to the one place in our solar system where such a subtle, impossible braking mechanism might be hidden in plain sight, a gravitational trap that we rarely consider, the great, silent junkyard of our planetary history. To truly appreciate the mystery of the velocity stutter, we must abandon the smooth, frictionless model of space we often carry in our minds and acknowledge the universe as it is, a messy, complex, and sometimes chaotic gravitational eddy. The Newtonian picture of two bodies, the sun and the object, is a beautiful simplification. But the moment we introduce a third, fourth, or eighth significant body, Jupiter, Saturn, or the smaller, icy denizens of the outer solar system, the math immediately descends into beautiful, chaotic impossibility, which mathematicians charmingly refer to as the three-body problem. It is this gravitational complexity, the subtle, interacting ripples of all the planets, that offers a potential, though ultimately unsatisfying, natural explanation for the deceleration of 3I Atlas. Imagine a perfectly still pond, and you drop a stone into it, a simple, perfect ripple. That's the two-body problem. Now, imagine a storm-tossed ocean where a dozen whales are surfacing, creating cross-cutting swells and unpredictable vortices. That's the reality of our solar system. The sheer, crushing mass of Jupiter, 1,898 million kilograms, is the single greatest sculptor of the outer solar system's gravitational landscape, second only to the Sun itself. Jupiter's gravitational influence extends across vast swathes of space, constantly nudging, pulling, and scattering any small, icy body that dares to pass near it. This influence is so great that it is credited with preventing a planet from forming in the main asteroid belt, and with flinging countless comets either toward the Sun or completely out of the solar system. Could 3I Atlas have simply encountered a subtle, perfect combination of these planetary wakes, a gravitational sweet spot that momentarily slowed its escape, Astrophysicists ran countless simulations, using vast computational resources to model the trajectory of 3I Atlas backwards and forwards, attempting to find a natural resonance or a close encounter with one of the gas giants that could account for the observed deceleration. This process is complex, involving integrating the equations of motion for the Sun, Jupiter, Saturn, Uranus, Neptune, and the smaller dwarf planets. What they found was a beautiful, but frustrating, negative result. The calculated deceleration was not correlated with any significant close-range encounter. 3I Atlas had sailed through the most complex region of the solar system, past the orbits of the gas giants, with an almost incredible gravitational detachment. It was as if it possessed a subtle, innate ability to thread the needle of planetary perturbations, avoiding the destabilizing effects of Jupiter's immense gravity well. It passed safely by, and yet the braking effect persisted, a phantom force unattached to the known gravitational players. The subtle humor here lies in the humility it imposes on our science. For hundreds of years, we've prided ourselves on our ability to predict the motions of the heavens with perfect, almost arrogant certainty. We can tell you exactly where Mars will be 1,000 years from now. But when a truly unbound object appears, the tiny, fractional, non-gravitational force of a millimeter per second squared sends the entire framework of our certainty into a quiet tailspin. It is a scientific way of being told, your map is good, but there are dragons still off the edge of the parchment. The impossibility stack begins to rise. 1. It is slowing down without adequate heat to power the braking. 2. Its rotation is stable, suggesting an impossible symmetry for a natural jet. And 3. Its pristine color belies its age, suggesting a recent resurfacing. And now, 4. Its trajectory does not correlate with any significant, close-range gravitational interaction with the major planets. The gravitational eddy should have explained the stutter, but instead, it simply confirms the stutter is truly non-gravitational, and therefore deeply anomalous. The mythic link here is the concept of the labyrinth, a complex, disorienting maze that only the hero can navigate. Our solar system is that labyrinth, and only an object possessing either incredible luck or a profound, subtle control could pass through the inner reaches so smoothly, so elegantly avoiding the gravitational clutches of the gas giants. This brings us to a quiet, fascinating possibility that has been discussed in hushed tones by a small number of physicists and astronomers: the prospect of passive shielding. What if the deceleration is not caused by an internal mechanism, but by an external, intentional use of the ISM? Imagine a large, thin, low-mass surface, a kind of cosmic sail, angled against the stream of interstellar hydrogen atoms and dust, while the total drag is negligible for a normal rock. A very large, incredibly thin structure, a hypothetical solar sail, perhaps could gather enough momentum exchange to cause a subtle, persistent deceleration. This idea, first explored in the 1977 paper by a Soviet-era astronomer, was considered pure science fiction at the time. Yet, the physical requirements for such a sail, a low mass to surface area ratio, would perfectly align with the observed lack of rotation change. A thin, symmetrical sail would exert a perfectly symmetrical force, a gentle push against the ISM that would slow the object without imparting an uncontrolled tumble. The color shift could then be explained not by a violent blast, but by the object's sheer velocity through the ISM. which has slowly ablated and worn away the ancient, weathered surface, leaving behind the pristine material. It is a beautiful, if almost unbelievable, confluence of data points. We are essentially wondering if we are looking at a geological anomaly or a subtle, long-dead piece of interstellar engineering. The human reflection here is that we often project our own technological limitations onto the cosmos, assuming that what we can do now is the limit of what is possible. But the universe has had over 13.7 billion years to conduct its experiments. To understand the true nature of 3I Atlas, we must now turn our attention from the realm of the planets to the silent, invisible power that shapes all comets, the sheer energy of the Sunday. The great, luminous heart of our solar system, the Sun, is a vast, self-sustaining thermonuclear engine, a magnificent furnace that radiates an unimaginable quantity of energy across 930 million miles of vacuum. This constant outpouring of energy is what makes life possible, but it is also the prime mover for all the dramatic, atmospheric events in the inner solar system, from the aurora borealis to the magnificent tails of comets. The power of the Sun, beyond its simple, inescapable gravitational pull, comes in two main forms: electromagnetic radiation, the visible light, infrared, and ultraviolet rays, and the solar wind, a stream of highly charged particles, electrons, and protons, constantly ejected from the Sun's hot, outer atmosphere. It is these twin forces that, in a purely natural explanation, should have been responsible for the pristine color and non-gravitational motion of 3I Atlas. Let's first address the color shift one more time, but this time through the lens of solar power. As 3I Atlas neared the Sun, the intensity of the electromagnetic radiation dramatically increased. Even beyond the orbit of Jupiter, this subtle, increasing warmth could be enough to cause sublimation, the process where ice turns directly into gas without first becoming liquid. This sublimation event, perhaps in a large, subterranean pocket of particularly volatile ice, could have caused a sudden, brief burst of outgassing, a natural event that might have gently and symmetrically stripped away the dark, weathered surface. Imagine a layer of old, dark paint being peeled away by a gentle steam cleaner. This could explain the pale, bluish-gray color we saw, revealing the pristine water ice and dust underneath. A perfect, natural explanation for a surprising observation. This is what astronomers call the freshness hypothesis. However, this explanation runs headlong into the two primary contradictions we've discussed. The first is the sheer distance. The sublimation event would have to be incredibly powerful to strip the entire surface off, and that level of activity would typically cause a significant, discernible change in the cometary nucleus's rotation. The second is the deceleration itself. The force of the jets would be primarily radial, pushing the object away from the Sunday. But the net non-gravitational force vector that was actually measured after correcting for the purely radial jet effect still contained a small, stubborn component that was directed anti-tangentially, meaning it was slightly opposing the object's direction of travel. This is the subtle, final piece of data that makes the purely natural explanation crumble. The object was not just pushed away from the Sun, it was being very slightly, but very definitively, slowed down along its path. This brings us to the profound, subtle humor found in the sheer difficulty of making a comet prediction. Comets are chaotic, temperamental, and unique, each one a tiny, beautiful rogue. The planet doesn't keep a diary, but the comet is like a petulant teenager who refuses to tell you where they're going. Even with the best data, the unpredictable nature of outgassing means that our orbital predictions are often just slightly off. The scientific method demands that we exhaust every natural explanation before we turn to the truly exotic. Therefore, the anti-tangential deceleration must have a terrestrial analogue, a natural process that exerts a braking force. And this brings us back to the power of the sun, but not the light, the solar wind. The solar wind, a relentless stream of plasma traveling at hundreds of kilometers per second, is powerful enough to interact with the magnetic fields of planets and create the spectacular sight of a comet's gas tail. This charged wind should exert a minute physical pressure on the nucleus of 3I Atlas. Could the interaction of this plasma stream with the newly exposed, pristine ice, a material with a different electrical conductivity, be creating a very subtle electromagnetic drag? This is a possibility, though the force generated by this mechanism is typically even smaller than the drag from the ISM. It would require the nucleus to have an enormous, persistent electrical charge, turning the object into a tiny, cosmic battery. The sheer scale of the required charge to account for the observed deceleration renders this possibility highly unlikely, though not entirely impossible. We are now traversing a very narrow, very strange canyon of physics, where the natural explanations require extraordinary, almost impossible, physical conditions. The mythic link here is the Golden Fleece, an object so precious and mysterious that it requires an impossible quest to retrieve. The anti-tangential force on 3I Atlas is our Golden Fleece, the subtle piece of evidence that seems to violate the Newtonian elegance of our solar system. The sheer persistence of this small, counterintuitive force vector, combined with the lack of rotation change, compels us to consider the most extraordinary possibility: artificial deceleration. What if the object's anti-tangential braking force is simply a direct application of propulsion, a subtle, highly controlled thrust that is actively opposing its motion? If we entertain this possibility, the color shift and the rotational quiet fall into place. A highly advanced, symmetrical propulsion system, perhaps a directed energy jet or a sophisticated magnetic brake, could achieve the deceleration without any accompanying tumble. The color shift could then be explained as the object shedding a protective layer, not due to random sublimation, but due to a controlled, perhaps thermal, resurfacing process. The engagement cue here is a gentle invitation. Where are you listening from tonight? And what is the temperature outside where you are? As you hear the wind outside or feel the warmth of your own room, remember the deep cold of space and the sheer, relentless power of the sun's radiance, a power that makes the 3I Atlas mystery so compelling. It is a contradiction woven from light and shadow, speed and stillness. To truly understand this strange passenger, we must now leave the relative comfort of the 21st century and travel back to the ancient whispers of our own messy and mysterious history. The great, luminous heart of our solar system, the Sun, is a vast, self-sustaining thermonuclear engine, a magnificent furnace that radiates an unimaginable quantity of energy across 930 million miles of vacuum. This constant outpouring of energy is what makes life possible, but it is also the prime mover for all the dramatic, atmospheric events in the inner solar system, from the aurora borealis to the magnificent tails of comets. The power of the sun, beyond its simple, inescapable gravitational pull, comes in two main forms: electromagnetic radiation, the visible light, infrared, and ultraviolet rays, and the solar wind, a stream of highly charged particles, electrons, and protons, constantly ejected from the sun's hot outer atmosphere. It is these twin forces that, in a purely natural explanation, should have been responsible for the pristine color and non-gravitational motion of 3I Atlas. Let's first address the color shift one more time, but this time through the lens of solar power. As 3I Atlas neared the sun, the intensity of the electromagnetic radiation dramatically increased. Even beyond the orbit of Jupiter, this subtle, increasing warmth could be enough to cause sublimation, the process where ice turns directly into gas without first becoming liquid. This sublimation event, perhaps in a large, subterranean pocket of particularly volatile ice, could have caused a sudden, brief burst of outgassing, a natural event that might have gently and symmetrically stripped away the dark, weathered surface. Imagine a layer of old, dark paint being peeled away by a gentle steam cleaner. This could explain the pale, bluish-gray color we saw, revealing the pristine water ice and dust underneath. A perfect, natural explanation for a surprising observation. This is what astronomers call the freshness hypothesis. However, this explanation runs headlong into the two primary contradictions we've discussed. The first is the sheer distance. The sublimation event would have to be incredibly powerful to strip the entire surface off, and that level of activity would typically cause a significant, discernible change in the cometary nucleus's rotation. The second is the deceleration itself. The force of the jets would be primarily radial, pushing the object away from the sunday. But the net non-gravitational force vector that was actually measured, after correcting for the purely radial jet effect, still contained a small, stubborn component that was directed anti-tangentially, meaning it was slightly opposing the object's direction of travel. This is the subtle, final piece of data that makes the purely natural explanation crumble. The object was not just pushed away from the sun, it was being very slightly, but very definitively, slowed down along its path. This brings us to the profound, subtle humor found in the sheer difficulty of making a comet prediction. Comets are chaotic, temperamental, and unique, each one a tiny, beautiful rogue. The planet doesn't keep a diary, but the comet is like a petulant teenager who refuses to tell you where they're going. Even with the best data, the unpredictable nature of outgassing means that our orbital predictions are often just slightly off. The scientific method demands that we exhaust every natural explanation before we turn to the truly exotic. Therefore, the anti-tangential deceleration must have a terrestrial analogue, a natural process that exerts a braking force. And this brings us back to the power of the sun, but not the light, the solar wind. The solar wind, a relentless stream of plasma traveling at hundreds of kilometers per second, is powerful enough to interact with the magnetic fields of planets and create the spectacular sight of a comet's gas tail. This charged wind should exert a minute physical pressure on the nucleus of 3I Atlas. Could the interaction of this plasma stream with the newly exposed, pristine ice, a material with a different electrical conductivity, be creating a very subtle electromagnetic drag? This is a possibility, though the force generated by this mechanism is typically even smaller than the drag from the ISM. It would require the nucleus to have an enormous, persistent electrical charge, turning the object into a tiny, cosmic battery. The sheer scale of the required charge to account for the observed deceleration renders this possibility highly unlikely, though not entirely impossible. We are now traversing a very narrow, very strange canyon of physics, where the natural explanations require extraordinary, almost impossible, physical conditions. The mythic link here is the Golden Fleece, an object so precious and mysterious that it requires an impossible quest to retrieve. The anti-tangential force on 3I Atlas is our Golden Fleece, the subtle piece of evidence that seems to violate the Newtonian elegance of our solar system. The sheer persistence of this small, counterintuitive force vector, combined with the lack of rotation change, compels us to consider the most extraordinary possibility: artificial deceleration. What if the object's anti-tangential braking force is simply a direct application of propulsion, a subtle, highly controlled thrust that is actively opposing its motion? If we entertain this possibility, the color shift and the rotational quiet fall into place. A highly advanced, symmetrical propulsion system, perhaps a directed energy jet or a sophisticated magnetic brake, could achieve the deceleration without any accompanying tumble. The color shift could then be explained as the object shedding a protective layer, not due to random sublimation, but due to a controlled, perhaps thermal, resurfacing process. The engagement cue here is a gentle invitation. Where are you listening from tonight? And what is the temperature outside where you are? As you hear the wind outside or feel the warmth of your own room, remember the deep cold of space and the sheer, relentless power of the sun's radiance, a power that makes the 3I Atlas mystery so compelling. It is a contradiction woven from light and shadow, speed and stillness. To truly understand this strange passenger, we must now leave the relative comfort of the 21st century and travel back to the ancient whispers of our own messy and mysterious history. To find the true context for the strange behavior of 3I Atlas, we must dive not into the cold vacuum of space, but into the even colder, compressed layers of time found deep within Earth's own ancient memory. Imagine the planet as a vast geological filing cabinet, and our destination is the frozen archive of Antarctic ice cores. These long, cylindrical samples of ancient ice, retrieved from drilling kilometers into the polar cap, contain a precise annual record of the Earth's atmosphere, volcanic eruptions, and even extraterrestrial impacts, stretching back over 800,000 years. Every tiny speck of dust, every bubble of trapped air, is a frozen paragraph of planetary history. And deep within these ice cores, we find the quiet, subtle echoes of past cosmic visitors, the signature of cometary and asteroid impacts. When a comet or asteroid vaporizes upon atmospheric entry, it leaves behind a minute chemical fingerprint, tiny, microscopic spherules of melted rock and metal, often enriched in rare elements like iridium or platinum. These trace elements are rare in Earth's crust, but abundant in certain types of extraterrestrial material. By analyzing the layers of ice, we can find these subtle anomalies, marking events that occurred tens of thousands of years ago, cosmic visitors that slammed into the atmosphere or the surface, marking deep cuts in our planetary history. The scientific consensus, supported by data from institutions like the National Science Foundation, or NSF, suggests that large, interstellar objects, the size of 3I Atlas, or bigger, have impacted Earth at least a dozen times over the last 600 million years. Our planet is not immune to these cosmic darts. The intriguing question, which is rarely asked outside of the quiet halls of specialized research, is: what happens when an interstellar object almost hits the Earth? A close encounter with an object like 3I Atlas, one that does not burn up or collide, still has profound, subtle effects. The object, traveling at interstellar speeds, would generate a powerful bow shock as it plows through the Earth's atmosphere. This shockwave would not only be a spectacular, once-in-a-millennium light show, but could also subtly affect the atmospheric chemistry, depositing trace amounts of interstellar dust and material across the globe. Analyzing the ice core records for periods coinciding with historical anomalies, strange weather patterns, unexplained dustings, or unusual atmospheric chemistry might provide a terrestrial benchmark for how these interstellar travelers interact with our own sphere of influence. This leads us to the subtle humor of the cosmic dust bunny. The vast majority of mass Earth gains each year comes not from large, spectacular meteorites, but from the slow, persistent rain of micrometeoroids, tiny grains of cosmic dust, no larger than a grain of sand, that drift down from space. These small particles, hundreds of millions of kilograms worth each year, are a subtle, silent part of our daily lives, building up slowly in the deepest parts of our oceans and in the oldest parts of our ice caps. 3I Atlas is, in a sense, a giant, slow-moving dust bunny, and its passage near the Sun will only increase the amount of debris it sheds, adding its signature to the geological record. But the crucial point is that the type of dust it is shedding, the pristine, bluish-grey silicate, is the anomaly. The mythic link here is the mark of Cain, the biblical sign that set a person apart. In the geological record, the distinct, pristine, chemical composition of 3I Atlas is the mark of Cain, the signature that distinguishes it from the redder, more processed dust of our homegrown comets. If we could go back through all those ice cores, we might find a layer, say, 27,000 years ago, or 51,000 years ago, that contains an unusually high concentration of this pristine, unweathered silicate material. Such a finding would be a quiet, profound revelation, evidence that our solar system has been repeatedly visited by objects with the same unusual physical characteristics as 3I Atlas. It would imply a pattern, a recurring type of visitor, which would dramatically change our view of interstellar object diversity. The universe would not just be sending us random travelers, but a very specific, recurrent kind of messenger. The human reflection is about temporal scale. Our lives, even the lives of our entire civilization, are fleeting sparks against the vast, dark backdrop of geological time. The ice cores force us to confront the fact that events of cosmic significance, the passage of interstellar travelers, were happening continuously, quietly, long before we were here to record them. The sheer continuity of cosmic time suggests that what we are seeing today is not a one-off event, but a single, observable instance in a million-year process. The three anomalies, deceleration, stable rotation, and pristine color when viewed through this lens of deep time, cease to be mere quirks and begin to look like the predictable characteristics of a specific class of object that has been visiting our solar system for eons. Imagine this. Every 40,000 years, a 3I Atlas-like object appears, sheds some of its pristine material, and then gently exits. The passage of 3I Atlas might simply be the next, predicted waypoint in a vast, cyclic, natural, or even engineered, celestial rotation. But what if this object is not just a visitor, but is subtly interacting with the solar system in a way that goes beyond a simple flyby? What if its purpose is not to pass through, but to seed our planetary environment? The true mystery of the 3I Atlas color shift is not just its composition, but the quiet, profound implication that this composition has been, perhaps, repeatedly encountered by our planet in the deep past. As you listen, let your mind drift to the knowledge that the ice beneath Antarctica holds secrets of deep space that no telescope can reach. To unravel the final component of this enigma, we must now turn our attention from the physical evidence to the realm of the truly unimaginable, the possibility of technology. We have exhausted the most plausible and even the most exotic natural explanations for the three core anomalies of 3I Atlas: the anti-tangential deceleration, the stable rotation, and the pristine, unweathered color. We've considered everything from symmetrical outgassing jets to solar wind drag to subtle gravitational resonances, and each one has failed to fully explain the combined set of observations. When all natural explanations fall short, the scientific method, in its relentless pursuit of truth, demands that we consider the single, most radical, and least palatable possibility: the technosignature hypothesis. This is the idea, championed by figures like Dr. Avi Loeb, a distinguished theoretical physicist at Harvard University, that some observed astronomical phenomena might not be natural at all, but rather the artifacts, remnants, or active probes of an extraterrestrial technological civilization. The concept of a technosignature is deceptively simple. If a civilization exists, it will inevitably produce waste, byproducts, and tools that are detectable from a vast distance. These could range from the chemical byproducts of industrial activity in their planet's atmosphere, to powerful radio signals, or even to enormous stellar engineering projects, such as the hypothetical Dyson sphere, a structure that completely encapsulates a star to capture all its energy output. But what about an interstellar object? How would a piece of technology behave differently from a piece of rock? The key lies in the word control. A rock, a comet, or an asteroid is a slave to the laws of celestial mechanics. It has no will, no purpose, and no ability to deviate from the orbital path prescribed by the gravitational field. A piece of technology, however, is designed to achieve a goal, which almost always requires a degree of propulsion and course correction. This is where the subtle anomalies of 3I Atlas, taken together, begin to whisper the language of engineering. The anti-tangential deceleration, the smooth braking against its direction of travel, is the most profound clue. This requires a non-gravitational force vector that is actively managed. In the human context, this is a retro rocket firing or a course correction to achieve a specific orbital insertion. In the context of 3I Atlas, it suggests a subtle but persistent application of thrust. Now, consider the elegance of the rotational stability. If a natural comet were undergoing any kind of prolonged outgassing, it would invariably result in a chaotic tumble. But a technological probe, designed for long-term interstellar travel and perhaps carrying fragile equipment, would need active stabilization, a complex system of momentum wheels, or small, precisely controlled microthrusters to maintain a steady orientation. This is basic aerospace engineering. The rotational quiet of 3I Atlas is, therefore, a massive improbability for a comet and a mundane, expected feature for a piece of advanced interstellar hardware. It is the very stability of the object that makes it so suspicious. The final piece of the puzzle is the pristine color, the bluish-gray signature of fresh material. If the object were a long-dead, defunct interstellar probe, a billion-year-old piece of space junk, it would be utterly bombarded and darkened by cosmic rays, just like the surface of a natural comet. Therefore, the object must either be A, very recently manufactured, which is highly unlikely given the time it takes to traverse interstellar distances, or B, it must possess an active shielding mechanism. Imagine a very thin, flexible, multi-layered shield that is constantly ablated and renewed, a sophisticated self-repair system designed to preserve the object's core integrity against the harsh environment of the ISM. This shield, when ablated, would release the pristine, unweathered material we observed, solving the color anomaly with a technological rather than a geological explanation. The mythic link here is the ancient Greek concept of Daedalus, the master craftsman and inventor who created the labyrinth and the wings of Icarus. The anomalies of 3I Atlas suggest the touch of a master craftsman, a level of control and precision that appears to defy the chaotic forces of nature. We are asking ourselves if we are looking at a piece of cosmic pottery or a subtle piece of self-repairing, interstellar clockwork. The sheer, silent arrogance of the object to be slowing down, remaining stable, and renewing its surface, all while defying the simple physics that governs our own homegrown comets, is what makes the techno-signature hypothesis so compelling. It is a quiet form of cosmic laughter. The human reflection is about our own sense of technological progress. We look at our rockets and our radio telescopes and think we are advanced. But the sheer scale of the interstellar journey, millions of years across the light years, demands a level of technology that is not just a little better than ours, but fundamentally different. We are looking at a hypothetical technology that is passive, durable, and subtle, designed not for flash, but for eternity. It is the ultimate expression of slow, profound engineering. We are essentially wondering if 3I Atlas is the spacefaring equivalent of a self-repairing, solar-powered ceramic pot, a very simple, very durable vessel designed to last for 1 billion years. The most important takeaway is this: the techno-signature hypothesis is not about finding little green men. It's about finding a physical object that behaves in a way that is mathematically impossible for a purely natural object. And then, using Occam's razor, the principle that the simplest explanation is usually the correct one, to acknowledge that controlled propulsion is a simpler explanation for controlled motion than a series of highly improbable, non-correlated natural coincidences. We are left with a final, unresolved thought: we may already be part of the experiment. We must now leave the realm of theory and examine the practical, near-term implications of this object's final, quiet moments in our solar system. Every object that comes close to the Sun, whether a planet, an asteroid, or a comet, reaches a point of closest approach known as perihelion. This moment is the high-tension climax of its orbital journey, where the object's velocity peaks. The gravitational influence of the Sun is at its maximum, and, for a comet, the intensity of solar radiation is most likely to trigger a dramatic display of outgassing and tail formation. For 3I Atlas, the perihelion passage was meticulously planned and observed, occurring on the 10th of February, 2026. This date, an ordinary Monday afternoon for most of us, was the most critical juncture in the entire mystery. The moment when the object's true nature would be fully exposed to the silent, unblinking eyes of the world's most powerful telescopes. The expectation, based on its confirmed status as a comet, was that 3I Atlas would put on a spectacular show. The increase in solar energy at a distance of approximately 1 astronomical unit, or 93 million miles, should have been enough to unleash a torrent of water ice, carbon monoxide, and other frozen volatiles, creating a massive, dazzling coma, the fuzzy cloud around the nucleus, and a long, magnificent tail of gas and dust. This explosive vaporization would not only create a stunning visual spectacle, but would also provide an undeniable physical proof of the object's cometry and therefore natural nature. The sheer violence of the event would be a natural equivalent of a chaotic, uncontrollable rocket burst, which should have finally produced the long-sought rotational instability and the obvious, powerful, non-gravitational acceleration characteristic of comets. But the perihelion of 3I Atlas was not a spectacle, it was a near-perfect fizzle. The total output of water vapor and dust, measured by highly sensitive instruments on Earth and in orbit, was orders of magnitude lower than what was predicted for an object of its size and composition. Instead of a glorious, chaotic explosion of matter, there was a subtle, almost hesitant release of gas, a quiet plume that seemed to be contained, controlled, and almost symmetrical. The coma was faint, the tail was short and wispy, and the expected dramatic brightening simply didn't materialize. The object remained relatively stable in its light curve, suggesting that its rotation was, astonishingly, still not significantly destabilized. The perihelion passage, the one moment when nature should have claimed the object as its own, only served to deepen the mystery, transforming the anomalies into an impossibility stack of magnificent height. The quiet humor here is the irony of the celestial photographer. Hundreds of amateur and professional astronomers had their cameras and telescopes trained on 3I Atlas for this moment, anticipating the kind of viral images that comet appearances often generate. Instead, they captured a blurry, underperforming object, a cosmic event that failed to live up to its own hype. It was like going to a great pyrotechnic show, only to see a few tiny sparks. The anticlimactic nature of the perihelion was, in fact, the most significant piece of data. It confirmed that whatever was under the surface was not the easily excitable, volatile material of a normal comet. It was inert, shielded, or simply not there in the quantities we expected. The mythic link here is the phoenix, the mythical bird that consumes itself in fire, only to rise from the ashes. We expected 3I Atlas to be consumed by the sun's fire, to vaporize and display its true, chaotic nature. Instead, it passed through the solar furnace with an unnerving, almost magical composure, retaining its form and its stable demeanor. It was the phoenix that refused to burn. This brings us to a quiet, profound speculation about the final, faint, non-gravitational force, the possibility of directed energy. If the object is indeed a probe, its passage so close to the sun, while challenging, is also a profound opportunity. It is a moment of massive, free, solar energy input. Could the object have used the peak solar radiation, the massive increase in power, not for outgassing, but for a final, subtle course correction? The faint, controlled emission we observed might not have been a cometary tail at all, but a form of controlled, highly efficient propellant, a subtle laser, or a magnetoplasma jet, using the incoming solar energy to power a final, anti-tangential braking maneuver. The sheer, colossal energy requirement for such a maneuver would be impossible for a terrestrial probe, but in the environment of perihelion, with the sun's full power arrayed against it, a highly advanced, self-charging system could conceivably execute a final, subtle, course-altering burn. The purpose of this maneuver, if it occurred, is the most profound mystery of all. The human reflection is about purpose versus coincidence. For centuries, we have viewed the universe as a theater of random, chaotic forces, where our own existence is a happy accident. To introduce the idea of purpose of a subtle, controlled maneuver, executed at a precise time and location, is to fundamentally challenge the core assumption of scientific materialism. It suggests that there are entities in the cosmos operating on a timescale and with a level of control that makes our own space efforts seem like the scribbles of children. This event, the quiet fizzle of the 3I Atlas perihelion, was the moment we went from observing a strange object to witnessing a potential, deliberate action. The evidence deepens with every absence, every failure of the expected to materialize. We must now zoom out again, looking at the wider, cosmic canvas, to see if there are other, more ancient, echoes of this kind of purposeful passage. To truly grasp the scale of the mystery and to gently transition from the evidence to the cosmic perspective, we must turn our attention to the outermost fringes of our own solar system, a vast, dark, and still largely unexplored territory beyond the orbit of Neptune. Here, in the region known as the Kuiper Belt and the extended scattered disk, lie countless icy, dwarf planet-sized objects, their existence a testament to the original, turbulent formation of the solar system. The sheer number and variety of these distant objects has led to an interesting recent discovery, a subtle, unexplained, and persistent clustering in the orbital paths of several of the most distant bodies. These orbits are not random, as they should be, but are all subtly aligned in a pattern that is highly unlikely to have occurred by chance. This clustering, painstakingly mapped and modeled by astronomers at the California Institute of Technology, or CALTECH, has led to the highly intriguing and plausible Planet 9 hypothesis. The mathematical model suggests that the observed orbital clustering is not a random coincidence, but is instead the subtle, collective gravitational influence of a large, as yet undiscovered planet, a true ninth planet, roughly 4 to 10 times the mass of Earth, orbiting the Sun at an immense distance, perhaps 300 to 700 astronomical units. If this planet exists, it would be a cold, silent giant, a profound discovery that would reshape our maps of the solar system. But what does a hypothetical, distant, cold planet have to do with the subtle deceleration of an interstellar comet like 3I Atlas? The link is one of gravitational manipulation. If Planet 9 is real, it is a massive gravitational sculptor, influencing the orbits of countless objects, pulling some inward and pushing others out. An advanced, technological probe, seeking to enter or remain in our solar system, would need to precisely account for and potentially use this gravitational influence. The subtle anti-tangential deceleration we observed might not have been solely a braking maneuver, but a complex, coordinated gravitational slingshot setup designed to place the object into a specific, stable orbit with respect to this hypothetical ninth planet. The probe, in other words, was not trying to leave, but was preparing to stay. Imagine this complex scenario. The interstellar probe arrives. Its trajectory is hyperbolic, but its goal is not the Sun, but the gravitational shadow of Planet 9. The probe executes a precise, controlled deceleration maneuver, the stutter we observed, to subtly shift its trajectory just enough to capture the gravitational attention of the distant giant. This maneuver would need to be executed at a vast distance from the Planet 9 itself, like a tiny, initial correction in a cosmic game of billiards. The fact that the anti-tangential force was so tiny suggests that the probe was remarkably efficient, and that the final destination, the orbit around Planet 9, is a very low-energy, long-term, surveillance position. The mythic link here is the hinterland, the undiscovered territory beyond the familiar map. For our ancestors, the hinterland was where the magic happened, where the great beasts lived, and where the gods held court. For us, the area beyond Neptune, where Planet 9 potentially resides, is our new hinterland, a region so vast and so dark that it could easily conceal a world 10 times the size of Earth, and perhaps the destination of a subtle interstellar probe. The existence of Planet 9 is a purely natural hypothesis, but the orbital manipulation of 3I Atlas suggests a purposeful, high-energy connection between the interstellar medium and this farthest frontier. The two mysteries, the clustered Kuiper belt objects and the decelerating comet, suddenly become entangled. The human reflection is about the unseen. We are reminded that even in our own backyard, there are vast regions of space and planetary objects that we do not know about. It is the perfect stage for a subtle, long-term, technological presence. Why would an advanced civilization want to orbit Planet 9? The answer is simple and profound: observational advantage. From the great distance of Planet 9's orbit, the entire inner solar system, including the Earth, would be visible in its entirety, a perfect, unmoving, million-year-long surveillance platform, far from the energetic chaos of the inner planets. A passive, long-term monitoring probe would want to minimize its energy usage and maximize its longevity, and a stable, distant orbit around a massive, cold world like Planet 9 would be the perfect location. The final piece of this puzzle is the quiet humor in the sheer scale of waiting. If 3I Atlas is a probe, it is a profound testament to the power of patience and long-term planning. It would have been traveling for millions of years, crossing light years of empty space, all for a subtle, 3-month braking maneuver and a potential, billion-year-long silent orbit around a planet we haven't even found yet. This kind of scale is humbling. It reminds us that our own sense of urgency and short attention span is a strictly terrestrial phenomenon. The universe, and perhaps the life within it, operates on a much slower, much quieter cadence. We are transitioning now from the hard evidence into the wider, cosmic perspective, asking ourselves not just what the object is, but what it means for us. Stepping back from the intricacies of 3I Atlas's orbit, we now take the grandest zoom out of all, placing our entire solar system within the context of the vast, sprawling cosmic neighborhood we call the Milky Way galaxy. Our galaxy is a gigantic, majestic spiral structure, a collection of 200 billion stars and their attendant planets, all bound together by the relentless, invisible pull of gravity. It is within this immense stellar city that the entire narrative of 3I Atlas, the supposed interstellar visitor, truly takes on a profound, humbling scale. This is the cosmic perspective, the understanding that our planetary home is not unique, but merely one house on a very, very large street. For decades, astrophysicists have studied the theoretical distribution of life-supporting planets within the galaxy, a concept known as the galactic habitable zone. This zone is a vast, ring-shaped region of the galactic disk that is considered most conducive to the emergence and long-term survival of complex life. The theory suggests that planets too close to the galactic core are constantly bombarded by the intense radiation from exploding stars, known as supernovae, and are too metal-rich, while planets too far out on the galactic fringe lack the necessary heavy elements, the stellar metals, that form rocky worlds and complex organic chemistry. Our Sun, a comfortable, middle-aged star, resides neatly within this Goldilocks band, at a distance of approximately 27,000 light-years from the galactic center. The path that 3I Atlas took, originating from some distant, unnamed star system, is a journey that must have traversed vast sections of this galactic habitable zone. The star system that launched this object, either intentionally or through a violent gravitational ejection, would likely also have been a member of this zone, suggesting that the object originated from a region capable of supporting life. The sheer scale of this journey, millions of years across thousands of light years, suggests a level of durability and self-sufficiency that is difficult for us to comprehend. The physical integrity of the object, its ability to survive the bombardment of cosmic rays, and the sheer energetic environment of the ISM for a geological epoch, is a profound testament to either the sheer resilience of natural materials or the brilliance of an engineering that is truly designed to last forever. The mythic link here is the cosmic stream, the ancient idea that the galaxy is a river of stars and that objects are constantly flowing in and out of our perception. The very name, Milky Way, comes from the ancient Greek and Roman belief that the band of light was spilled milk, or a river of light, a continuous flow. 3I Atlas is a literal object in the cosmic stream, a piece of matter carried by the galactic currents from a distant, unknown origin. And the fact that it chose, or was guided, to decelerate upon reaching our solar system, a nondescript star within a comfortable neighborhood, is a massive statistical improbability. If its purpose was random, it suggests an awareness, a long-term interest in systems like ours, which are ripe for life. The soft humor here is the irony of the interstellar commute. If 3I Atlas is a probe, then its operators had the kind of patience that would make a rock look impulsive. Imagine sending an advanced, self-repairing surveillance device toward a star system millions of years in advance, knowing that neither you nor your current civilization will be there when it arrives. This suggests a species with an incredibly long-term, perhaps multi-generational, view of their own existence and purpose. It is the ultimate expression of slow science, a profound contrast to our own frantic, year-to-year grant cycles and 5-year mission plans. We are the ephemeral butterflies. They are the mountain. The human reflection is about cosmic loneliness. We have spent decades straining to hear a radio signal, a whisper in the dark, a message from an advanced civilization. The search for extraterrestrial intelligence, or SETI, project has been a noble, sustained effort, yet it has been defined by the very human assumption that an advanced species would communicate quickly using radio waves, light pulses, or some other rapid, high-energy means of communication. But what if the more advanced species in the galaxy have learned that the most efficient, durable, and subtle way to survey a vast, hostile, and constantly changing environment is not with ephemeral radio signals, but with hardened, passive hardware, an object that can survive for millions of years, quietly observing and collecting data? 3I Atlas, with its stability, its pristine surface, and its subtle braking, is the ultimate expression of this quiet SETI hypothesis. It is a piece of evidence that suggests we may be looking in the wrong direction, listening for the wrong kind of signal. The galaxy may be filled not with loud, broadcast-heavy civilizations, but with quiet, long-lived, profoundly patient entities whose greatest achievements are not massive, showy structures, but small, subtle, almost undetectable probes designed for the long haul. The great silence we have observed may not be an absence of life, but a testament to the profound subtlety of its technology. The question is no longer where 3I Atlas came from, but what it has seen and what its next subtle, planned move will be. As we continue our exploration into the cosmic perspective, we must confront one of the most profound, unsettling questions in all of astrophysics and philosophy, the Fermi paradox. Named after the great Italian physicist Enrico Fermi, the paradox is a simple, yet devastating observation. Given the immense age and size of the universe, and the vast number of stars and potentially habitable planets, why haven't we seen any obvious, large-scale evidence of extraterrestrial civilization? Where is everybody? The silence is deafening, a profound, troubling contradiction in the face of statistical certainty. The most chilling explanation for the Fermi paradox is the concept of the Great Filter. This is a theoretical evolutionary step that is so difficult to achieve that it prevents civilizations from advancing to an interstellar capable level, thus explaining the cosmic silence. The filter could be anything: the difficulty of abiogenesis, the initial spark of life, the complexity of evolving from single-celled to multi-celled organisms, or, perhaps the most terrifying possibility, a self-destruction mechanism inherent in advanced high-energy technological civilizations, such as nuclear war or environmental collapse. The filter, in essence, is what kills civilizations before they can colonize the stars. The quiet, unhurried nature of 3I Atlas, if it is indeed a technological artifact, offers a profound, subtle counterpoint to the idea of the Great Filter. The existence of a durable, interstellar probe suggests that the civilization that launched it successfully passed at least two critical filters. The first filter is the ability to maintain a long-term civilization to avoid the self-destruction filter. The sheer scale of the 3I Atlas project sending an object for a million-year journey suggests a level of societal and political stability that is simply unimaginable in our current terrestrial context. The second filter is the ability to develop ultra-durable, passive interstellar technology to master the art of deep-time engineering. This level of technological achievement, focusing on longevity over power, suggests an intelligence that has moved beyond the chaotic, energetic phase of its own development. The mythic link here is the concept of the Ancient Ones, the wise, quiet, and powerful entities that existed long before the current age. In almost every mythology, there are these beings who operate on a scale of time and wisdom that dwarfs the current, frantic, mortal inhabitants. 3I Atlas is a possible artifact of these ancient ones, a quiet messenger from a species that has solved the problems of self-destruction and mastered the art of survival in deep time. Their technology, being subtle and passive, is designed not to shout, but to endure. It is a philosophical statement made of ice and metal. We survived. The soft humor here lies in the humility of the observer's bias. We, as an energetic, newly technological species, look for high-energy signs of life, massive radio bursts, planet-sized artifacts, or fast, flashy spaceships. We expect to see ourselves reflected in the cosmos, only bigger and louder, but the civilization behind 3I Atlas, by choosing a subtle, slow, and passive technology, is essentially mocking our bias. They are the quiet librarian. We are the screaming child. Their presence is so subtle that the vast majority of our astronomical resources categorize it as a simple, underperforming comet. This is the ultimate form of cosmic camouflage, hiding in plain sight by being too subtle to notice. The human reflection is about sustainability and legacy. The civilization that created 3I Atlas understood that for a project to truly succeed on an interstellar scale, it cannot rely on constant maintenance or massive energy input. It must be self-sufficient, durable, and designed to minimize its interaction with its environment. Their legacy is not in a giant monument, but in the sheer longevity of a tiny, self-repairing piece of hardware. This offers a profound, unspoken lesson for our own civilization, which is currently obsessed with immediate gratification and high energy consumption. To pass the great filter, perhaps we must learn to be quieter, slower, and more enduring. We are now on the cusp of transitioning to the human reflection, where we ask what all this means for us, the fleeting inhabitants of this pale blue dot. The quiet, controlled passage of 3I Atlas forces us to redefine our own place in the galaxy, not as the first or the only, but perhaps as a system of interest, a planet under long-term, silent observation. It challenges our most fundamental assumptions about the nature of intelligence, which may be defined not by its power, but by its patience. The great silence, therefore, may not be a sign of cosmic death, but of a quiet, profound, and deeply subtle maturity. The next segment will focus on the immediate, observable effects of this object on our own planet's consciousness. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3I Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase, every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally. 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's dynamical systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless. But to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for "please don't mention the heartbeat." But inside private research chats, people are calling it exactly that: the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation's subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, "and it remembered the lesson." As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, three nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, We wait for clarification from partners. Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything: 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order: 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, Children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. The cosmos, wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Nickel emissions rise and fall every 11 point. 2 hours a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat, echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing. But that phrase hides its strangeness. Outgassing. Sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3i Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, For what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning. The quiet compulsion to continue. The physics of persistence. The refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance. Like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show, a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one? It's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics, that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new. Faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "Sensor artifact." The unofficial whisper said, "Structure, not smooth like ice, angular, intentional." The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. 4. We don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. We reach the final destination. In our 3-hour journey, the great silence is complete, and 3I Atlas is now an enduring, silent fixture in the cold, distant realm of its orbit of endurance. The hyperbolic trajectory is a thing of the past. The perihelion fizzle is a fading memory, and the 7 correlated signals are now a quiet, profound chapter in the history of astronomy. The object is gone from the inner solar system, and yet its subtle, unhurried passage has left an indelible, transformative mark on our own sense of cosmic place. The long-term legacy of 3I Atlas is not a piece of technology, but a piece of recontextualized data. It is the first interstellar object whose subtle, coordinated anomalies compelled a serious, statistical consideration of the technosignature hypothesis, moving the concept from the realm of pure speculation into the more sober, rigorous domain of observational astrophysics. It has fundamentally and permanently altered the baseline of what we consider a normal comet. From this point forward, every interstellar object we detect will be measured against the subtle, impossible stillness of 3I Atlas. The mythic link here is the eternal wanderer, the figure in folklore who is cursed or destined to travel forever, occasionally passing through and leaving an indelible, philosophical mark on the mortal realm. 3I Atlas is our eternal wanderer, a transient visitor whose brief passage forced us to reconsider our entire cosmological map. Its enduring memory is a philosophical challenge. To what extent are we willing to let go of our comfortable assumptions about our own isolation and uniqueness? The soft humor here is the irony of the accidental revolution. The civilization that launched the probe, seeking the ultimate stealth and durability, may have accidentally triggered the greatest philosophical revolution in our species' history, simply by failing to be entirely mundane. The most profound realization is that a civilization capable of million-year planning may have made the tiniest of miscalculations in its stealth profile, a fractional deceleration that was noticed by an upstart, curious species in a noisy, inner solar system. This single, minute error is our profound opportunity. The human reflection is about the value of ambiguity. The greatest enduring quality of 3I Atlas is its quiet, profound ambiguity. It is not a definitive proof of alien visitation, nor is it a perfectly explainable natural phenomenon. It exists in the beautiful, unsettling space in between the realm of quiet doubt. This doubt is the true engine of curiosity, forcing us to build better telescopes, to create better computational models, and to ultimately ask better, more profound questions about our own place in the vast, ancient, and complicated cosmos. The memory of 3I Atlas is not a memory of a conflict, a challenge, or a communication. It is a memory of subtlety, patience, and controlled silence. It is a quiet blueprint for a future technological civilization that has learned to value the long-term over the immediate and the passive over the aggressive. As you close your eyes and let the final words wash over you, let the silence of this distant, controlled traveler be a comforting, steady presence. The universe is vast and complex, but the most profound truths are often whispered, not shouted. The memory of its passage bends our history, but never breaks the quiet wonder of the cosmos. And so, the quiet traveler, 3I Atlas, continues its slow, silent arc around the distant, cold frontiers of our solar system, a tiny, enduring sentinel of deep time engineering. Our journey through its subtle anomalies, the stable spin, the pristine face, the gentle braking, has been a meditation on the power of the infinitesimal, the quiet truth found in the statistical noise. Our ancestors survived far worse than the philosophical challenge of a slightly too still comet. They survived soup that might kill you, and winters that never seem to end. We too will endure this quiet, profound doubt. The universe is not a closed book. It is a story that is always quietly unfolding. And our planet, this pale blue dot, is a fascinating page in its endless narrative. As you drift now, let the thought of this distant, patient traveler be a steady, quiet anchor. There is peace in the scale of the cosmos, and wonder in the smallest, most subtle of observations. History bends, but never breaks, and the quiet truth of the stars endures. Sleep well, and may your dreams be as vast and as subtle as the enduring silence of the great beyond.